In previous videos, we have learned how to communicate with LLMs. We have sent prompts, received responses, but there is one important problem. The AI usually responds in plain English. That works perfectly for humans, but software applications don't understand paragraphs. Software prefers structured data. Imagine you are building an e commerce application. You ask the AI, extract the customer's name and phone number. If the AI replies, the customer's name is Rahul and his phone number is something 9876, a human understands it immediately. But your Java application now has to search the sentence, find the name, find the phone number, and hope the format never changes. That's unreliable for software. Instead, wouldn't it be better if the AI simply returned JSON? That's exactly what we will learn today. Humans are amazing at understanding natural language. If I write John lives in Bangalore and is 30 years old, you instantly understand. A computer doesn't. It doesn't know which word is the name, which word is the city, which number is the age. Computers prefer structured formats JSON, XML, CSV, database rows. That's why structured output is one of the most important concepts in AI development. Imagine in this example prompt extract customer information. Tomorrow the AI changes its wording. Instead of computer name, it writes name or client name. Your parsing code breaks. This is why relying on plain text is risky. LLMs are probabilistic. They don't always produce identical wording. Applications need consistency. Now compare this. Every value has a fixed key. The format is predictable. Java can easily deserialize this JSON into a POJO. That's why production AI systems almost always prefer structured responses. Notice this JSON response that isn't written for humans. This is much easier to work with, and that's exactly what we want. Once the AI returns JSON, Java can convert it directly into an object. No regular expressions, no string splitting, no searching. Spring automatically maps JSON to this class. Now, how do we ask for JSON? By using prompts, and that is known as prompt engineering. Notice we are not changing Java code, we are improving the instructions. We explicitly tell the AI return only JSON, don't explain, don't write paragraphs, don't use markdown. These small instructions dramatically improve reliability. Let's compare these two prompts. Our first prompt simply says extract invoice details. This is not wrong, but it's incomplete. The AI now has complete freedom to decide how it wants to present the answer. Sometimes it may return a paragraph, sometimes a table, bullet points, sometimes labels like invoice ID. Another time it may use invoice number. These responses are perfectly readable for humans. But imagine your Java application. If tomorrow the AI changes invoice number to invoice ID, your parsing code may stop working. Now look at the second prompt. We are very specific. We ask the AI to return only valid JSON. We explicitly define the field names. We also tell it not to include explanations or markdown. Now every response follow the same structure. This consistency makes our application much more reliable. One important lesson in prompt engineering is that AI performs best when your instructions are precise. Now let's see how we use this inside a Spring Boot application. The first thing we create is our prompt. Notice that the prompt is much more than a question. It's actually a set of instructions. We are telling the AI extract customer information, return only JSON. These are the fields I expect. Next, we pass this prompt into Spring AI, chat client.prompt. This creates a new request. Then user prompt sends our instructions as the user message. Next we do call. Spring AI performs the complete network communication. It creates the HTTP request, adds the API key, converts everything into JSON. sends it to OpenAI, waits for the response, receives the JSON, finally content method extracts the actual text returned by the model. If everything goes well, the response variable might contain something like name in the form of JSON format, name Rahul, phone number 9876 something, and city as Bangalore. At this stage, it's still a string. In next step, we will convert it into Java object. Let's understand the complete journey of a request. Everything starts with the user. Suppose the user uploads a resume or an invoice. The request reaches our Spring Boot application. Now we prepare a prompt. Instead of simply asking the AI, read this invoice, we give detailed instructions. For example, extract the invoice number, customer, amount, and return only JSON. This prompt is then passed to Spring AI. Spring AI creates the HTTPS request, adds authentication, creates the JSON payload, and sends everything to OpenAI. The AI processes the request and generates structured JSON. Spring AI receives that JSON. Our application then converts the JSON into a Java object. Once we have a Java object, everything becomes very simple. We can save it into a database, display it on a web page, call another REST API, or perform business validations. Let's look at some real world examples where structured output is extremely useful. Suppose a company receives thousands of resumes. Instead of manually reading them, the AI extracts information like name, skills, experience, education, phone number, email. The result is then returned as JSON and stored directly in the company's HR database. Now imagine an invoice processing application. Employees upload invoices every day. AI extracts invoice number, vendor, date, tax, amount, again all returned as JSON. No manual typing required. In banking, customer upload bank statements, the AI extracts transactions, balances, account numbers, and converts everything into structured JSON. Same way in HR applications, we extract employee information automatically. In hospital, we extract patient name, diagnosis, medicines, doctor name, hospital. Notice a common pattern in all these applications. The AI is not generating long paragraphs. It's acting as a data extraction engine. That's one of the biggest real world uses of LLMs in enterprise software. Today, we have taken another important step toward building production ready AI applications. You learned that while humans prefer natural language, software systems need structured data. By asking the LLM to return JSON instead of plain text, your Java application become more reliable, easier to maintain, and much simpler to integrate with databases, APIs, and business logic. You also saw that this improvement doesn't require changing your application architecture. Often it's just a matter of writing a better prompt and validating the response. In next video, we will go one step further and learn how Spring AI can automatically map LLM responses directly into Java objects, eliminating much of the manual parsing code. This is one of the most powerful features for building enterprise AI applications with Java. Thank you for watching. See you in next video.